Hello everyone. Today I'm going to be explaining, not just me and my friends and I are going to be explaining chapter 3 Form 4 at Maths, which are systems of equation. More specifically, we're going to be explaining about simultaneous equation involving linear and nonlinear, which is the subtopic 3.2 in chapter 3. Using factorization method. First of all, we're going to be seeing what we're learning today step by step. First of all, we're going to understand the concept and meaning behind simultaneous equation, how to do it, all. And then secondly, we're going to see the criteria needed in order to use factorization methods. I will explain this later. And then thirdly, we're going to see how to solve problems regarding on simultaneous equation involving linear and nonlinear. Then we'll see how these equations look in a graph. And then last but not least, my friends and I will give you a few examples of questions and how to solve them. Then, first of all, conceptual understanding. How to solve simultaneous equation in two variables? Well, you can either use substitution or elimination methods. In this video, I'm mostly going to be using substitution methods, but you can also use elimination. It's the same thing. You'll get the same outcome, the same answer. Secondly, how to solve a quadratic equation. You can solve it by either using CTS, which is completing the square, factorization, or quadratic formula. CTS and quadratic formula, you can use that in all types of equation, with all types of solutions. But factorization, like here, right here, we can only use factorization for a certain types of equation with certain solution, which is integer, rational number, and integer. So if the solution to the general form of that quadratic equation is neither of these, which is irrational numbers, then you need to either use CTS or quadratic formula. This is an example where the solution is an integer, so you can use factorization method right here. Yeah, like right here too. The solution is an integer. And then this is an example where the solution is an irrational number. So if we insert these numbers, 2, 120, and 1575 into the calculator, we'll get an irrational number. So when we get an irrational number, we cannot use the factorization method. Instead, we need to use either CTS or the quadratic formula. Right now, I'm going to show you how to solve step by step systems of equation involving linear and nonlinear. So first of all, make sure there are two equations. Equation 1 and equation 2. And then you need to make sure that there are only two variables. It can be x and y, or a and b, h and z, whatever, but it need to be two variables only. And then thirdly, we need to make sure that you need to make a third equation where one of the variables is the subject of formula. In example, x. And then we'll do substitution. We substitute this third equation into the equation that we haven't used yet. After that, we'll solve that equation that we have just made, that we have just substitute, and make the simplest form of quadratic equation, which is ax squared plus bx plus c. And then we'll substitute the values found in the third in what we have in the third equation. So when we did this substitution, we'll find, if we used x, we'll find what is x. So when we found what is x, we can use that to find the value of y. And the last but not least, make a conclusion. My friend SYAKIRAH, the second presenter today, will give you an example of a question, and you will see that these steps are applied there. This is a graph representation of the equations. So the subtopics that involve linear and non-linear. So this is a linear equation where the highest power is 1, and then this is a non-linear equation where the highest power of any of the variables is 2. You can see here the linear equation is a straight line, and the quadratic equation, the linear equation and the quadratic equation will graph a parabola. We can see also here that there are two intersections. So in any system of equation, the intersections are the solution to that system of equation, whether be it 3 variables or 2 variables. The intersections are the solutions to that equation. So in this case, there are 2 intersections, which means that there are 2 solutions. If there's only one intersection, like let's say this line here is up here, and then that it only intersects at one point, then that means there are only one solution to that sets of equation. Right now, like I said before, my second presenter, SYAKIRAH, will explain to you an example of a question involving simultaneous equation with linear and non-linear.
So the question is 3y minus x equals to 3 and 2 over 3y minus 1 over x equals to 2. So the equation is equation 1, 3y minus x equals to 3. Equation 2, 2 over 3y minus 1 over x equals to 2. And equation 3 from equation 1, make x as subject formula, so it will be x equals to 3y minus 2. So substitute 3 into 2. So it will be 2 over 3y minus 1 over 3y minus 3 equals to 2. So the answer will be 18y squared minus 21y plus 6 equals to 0. And after we got the equation, we need to simplify it. So simply divide 3 at both sides, and we got 6y squared minus 7y plus 2 equals to 0. Then factorize them, and we got 3y minus 2 times 2y minus 1 equals to 0. So after we factorize, we will get the values of y. So y equals to 2 over 3 and y equals to 1 over 2. Then substitute the values of y into equation 3. After we got the values of y, we need to substitute it into equation 3. So equation 3 is x equals to 3y minus 3. So if y equals to 2 over 3, then we insert the value of first y into equation 3. So it will be x equals to 3 times 2 over 3 minus 3. So we will get x equals to negative 1. So next, if y equals to 1 over 2, so x equals to 3 times 1 over 2 minus 3, then we will get x equals to negative 3 over 2. So the conclusion is x equals to negative 1, y equals to 2 over 3, or x equals to negative 3 over 2, and y equals to 1 over 2. So this is the graph of the end product.
My third presenter, Wan Julianis, will show you another example of a question involving simultaneous equation in 2 variables with linear and non-linear.
For question 2, solve x plus 1 over 3y equals 1 and y squared plus 2xy equals 34. With the equation given, we have to label it as equation 1 and equation 2. we have to choose the easiest equation so that we can make the third equation. So we choose x as the subject of formula, then it will be x equals to 1 minus 1 over 3y. That will be the third equation. And then we will have to substitute 3 into 2, equation 2. It will be y squared plus 2 in the bracket 1 minus 1 over 3y. Y equals to 24. And then we will have to expand it. After expanding it, we will get y squared plus 2y minus 2 over 3y squared equals to 24. Then we will get 3y squared plus 6y minus 2y squared equals to 72. From the equation we got, we have to equal it to 0. And then we will get y squared plus 6y minus 72 equals to 0. After getting this, of course we have to do factorization because we have the a, b, and c. It will be y minus 6, y plus 12 equals to 0. And that will make us with y equals to 6 and y equals to negative 12. To get x, we have to substitute the values of y that we got earlier into the equation 3. So the equation 3, if y was 6, if y equals to 6, x equals to y minus 1 over 3 in the bracket 6. And then we will get x equals to negative 1. If y was negative 12, it will be x equals to 1 minus 1 over 3 in the bracket negative 12. It will be x equals to 5. So in conclusion, x equals to negative 1 if y is equals to 6, or x equals to 5 if y equals to negative 12.
Next, AMEER will present to you another question.
Hello. Today we're gonna show how to solve this equation. First, we create the third equation. We simplify it from the second, so we can make the third equation, and then we substitute the third equation into the second, and then we solve the equation. And then we simplify it. We simplify it by dividing it by 2, so we can smaller the amount to make it more simple to solve it. After we get a smaller amount, which is right here, then we'll use the cross multiplication method. And then we extract the answer from the cross multiplication, and then we search for the x, which is right here. the x is negative 2 over 5 or x equals to 1. After we get the x, we use from the third equation to find the y. We use the equation and then we just put the x into the equation, so we got the y. The x right here got a 2 amount, so we should got 2 answer also. When we got the answer, don't forget to write the conclusion. And right here is supposed to have 2 answer. And then done. Ayo nak maju, easy. Thank you.
Hello everyone, I'm FARIHIN. I'm the first presenter of this show that I explained to you the graph representation, the conceptual understanding, and the methods and the steps that we have gone through to make this project a successful one. And right now, I will explain to you how to solve this question 4. Given that 5h is one of the solutions to the following simultaneous equation, h in bracket x minus y equals to x plus y minus 1 equals to hx squared minus 11y squared. Find h and the other solution. So as you can see here, there seems to be only one equation, one very long equation, but no, there's only to deceive you. In one equation, one thing equals another. So these things, h in bracket x minus y equals to x plus y minus 1 is an equation in and of itself. And then this equals to this is also another equation. So we can just separate that and make 2 equations, and then we can solve it like we normally do. The first things that they ask us to find is h. So how do we find h? Well, we know that the solution given is x equals to 5 and then y equals to h. As you can see here in a coordinate, the left side is x, the right side is y. So x equals to 5, y equals to h. We substitute that and then to the first equation because it's the easiest one. And then we'll get this. H in bracket 5 minus h equals to 5 plus h minus 1. 5h minus h squared minus 5 minus h plus 1. We multiply this and then we transfer this set of number and variables to here. So we minus 5 here, minus 5 here, minus h here, plus 1 here, and then we get this equals to 0. And then when we solve this, we find that the a here, ax squared plus bx plus c, remember that, we find that the a here is a negative number. In order to use factorization method, we need to make sure that the a is in positive number. Only then we can get the full mark in answering an exam. After that, we get this h squared minus 4h plus 4. Only then we can substitute, we can use this number, we can insert this number into the calculator, and we'll get the answer h equals to 2. And from h equals to 2 here, we can make it into two brackets. This is the factorization method here. When h equals to 2, we need to make sure that one of this bracket is equals to 0, so that if this equals to 0, then whatever the answer to this times this will equal to 0, and it goes both ways too. So if h equals to 2, how do we make an equation where the answer will be 0? Of course, h minus 2. because h equals to 2, 2 minus 2 equals to 0. Then it doesn't matter whatever the answer here is, because it will end up being multiplied by 0, and then make it into 0. So that is the factorization method. You take the answer, h equals to 2, you take the 2 here, and then you put the variable here, h, and then you if the answer is positive, you make it negative here, so that the outcome will be 0. Again, remember, factorization method, you take the variable here, and then you take the answer here and make it into the opposite form. If the answer is positive, make here negative. And then now that we found h, let's take a look at the next instruction. Find the other solution. So remember that 5 and h, in this case 5, 2, is one of the solution. If the question said that one of the solution is 5h, that means that there's two solutions here. So we need to substitute h, which is 2. We found that before this. We need to substitute that into the equation, so we get the third, the fourth, and the fifth equation. Here, the fifth equation is we make one of the variable the subject of formula. Now that we have one of the variable as the subject of formula, which is x, we can substitute that into the equation that we haven't used yet, which is 4. So we substitute 5 into 4, and then we'll get this x. So x is 3y minus 1. We'll substitute x into here. So 3y minus 1 squared, 2x squared. We do that, and then we get this. We insert these numbers into the calculator. We will get y equals to 2, and then y equals to 2 over 7. Oh no, there is a fraction. So how do we do this? Well, we know that, as stated before, you need to make sure that whatever the number here is equals to 0. So can you write 2 over 7 minus 2 over 7 equals to 0? No, you cannot. That will not grant you full mark. We need to make sure that in factorization method there is no you cannot write fraction in here. So then how do we do this? How do we convert those fractions into integer? Well, we simply multiply the denominator, in this case 7, into the next number here, or in this case variable. So 2 over 7, we times 2 over 7 by 7, and then we also times y by 7, we also times 0 by 7, and then we'll get and then we also times this by 7, so we get 7y minus 2 equals to 0. 0 times 7 is 0, and in this case here is also 0, so 0 times 7 is also equal to 0. We got 7y minus 2. This is how you convert fractions into integer. You just transfer the denominator next to the variable here. And then finally, we can find x. So how do we find x? We simply substitute the values of y into the fifth equation here. X equals to 3y minus 1. We substitute y, which is in this case 2 over 7. So why don't we use y equals to 2? Well, remember that h is already equals to 2. So the question asks us to find the other solution. So that means y cannot be equals to 2. So y equals to 2 over 7. We substitute that to the fifth equation. We multiply this, and then we get x equals to negative 1 over 7. Finally, the conclusion is h equals to 2. And if x equals to negative 1 over 7, y equals to 2 over 7. Here is the graph representation of these two equations here. H x minus y equals to x plus y minus 1, and h x squared minus 11y squared equals to x plus y minus 1. You can see these two are the solution. So x equals to negative 1 over 7. This is x negative 1 over 7. Y equals to 2 over 7 here. And then the other solution is that y equals to 2 and x equals to 5. So that is what it means, what the x and y means, what the solution means. Like I stated earlier in this video, the solutions mean the intersection points between these two lines. So in this case, the solutions the solutions are 5, x equals to 5, y equals to 2, and then also x equals to -1/7, y equals to 2/7. Thank you for watching.